Okay, so we are now going to be looking at our solutions for session 7. Um, and we are going to try to use our number sense to be able to make some questions more accessible to just a mental calculation. So we're going to start with number 1 here. We're going to use compensation to take this original problem and adjust it in a way that would make it possible to calculate mentally. Okay. And then we're going to use a number line to kind of explain why that works or why we're allowed to do that. Okay. So we're going to think about the compensation first, and then we're going to add our number line and sort of talk about the explanation for that. So basically, I'm starting out with 39 plus 47. We know if we were to give this exercise to students, okay, they would stack it up most likely and perform standard algorithm for addition. In other words, we would probably be looking at a situation like this where they would, add and carry. And most likely our elementary students are going to need paper pencil to do that. Okay. So what we want to do is we want to adjust this a little bit so that they can make that a mental calculation, be able to do it without paper pencil. We use number sense to do that. Now, how does that work? We have essentially adjusted some of the values in the problem so that that becomes possible. And that's why this is called, of course, compensation. Now, if you don't have number sense, this is going to be a little bit of a struggle to do, but if you do, it's going to be very, very simple. You can think about this as having 39 objects of anything you want to call them and 47 additional objects. Okay. Now, or we all should know, that when we put 39 and 47 objects together, no matter how we combine them or in what groups we make, we're going to result with 86 different objects in that collection. Okay. Now, how can we make that calculation easier? Now, clearly, we're not going to give them 86 objects, have them counted out, although we certainly could. Once we get to this point, we're thinking our students have developed some conceptual understanding of what it means to join or add. We just want to give them a strategy to mentally calculate this. Okay. Now, I know we've talked about that in class, but I like putting it together again before we start the homework to kind of get our brain motivated and thinking in the direction you want. Okay, so how am I going to make this easier? You'll notice that they've already kind of started you here. They've told you they're going to take 39 and they're going to turn it into 40. Okay, and now we've got to adjust the other amount so that it's still going to come out to be the same thing, just make it easier to calculate. Okay, so if this is new to you, it might help you to think about it this way. Here I started with 39 and I added 47 and then I came up with 86. I adjusted that by starting out with one more. Okay, I started out with 40. I want to add something that's still going to make this result to 86. Now, it shouldn't be hard to know, especially since we see the 40, that has to be 46. If we had just added 47 like always, we would have come out with 87. That would have been one too high. So the additional one I increased here, I've got to adjust this. I've got to compensate by taking that one away from here. All right. Now, in terms of our number line and why that works, okay, I'm going to start my number line at 35 just for space purposes, and I'm going to scale it by 5s. So it should be a large enough scale so that we don't use more space than is available, but a small enough scale that people will kind of still be able to understand our markings. Okay. All right, so I'm going to do this first, model this first calculation in a different color so it's easier to see. We're going to start with pink, okay? And I'm going to model this one with pink. So I'm going to start at 39, which is here, and I'm going to add 47, okay? Now, in elementary methods, one of the things you'll learn is the way that kids use their number line, okay? So they can think they're at 39, they add 1 to get to 40, right? So now they need to do 46 more. So if we're at 1 at 40, 40 puts us up to 80, right? So I've used 41. And now I need to do 6 more, which would put me at 86. And that's my calculation for this. Number lines are a very good strategy to help students add if that's something that they struggle with being able to do. It's the only manipulative they can always create themselves, so it's very helpful. And breaking up the distance takes advantage of easy math facts that kids are more likely to be able to recognize, such as tens and fives and so forth. So we have 40. We had 1 from 39 to get up to 40. We had 40 more to get up to 80. And then we had 6 additionals to get to 86. And of course, all of that's a distance of 47, which is what we wanted to add. Okay, now let's go back and let's do the other. And I'm going to choose a different color for that one. I don't know, maybe let's do purple for this one. And I'll underline it in purple. Now here in this problem, we start at 40 and we go up to 86. Okay, so we still ended at the same place, but we started at a different spot. Okay, I want to have the same end point no matter the strategy I choose, and that's why this works. Okay, that's why we have to make adjustments because we have the same goal. We want to get to the same sum, and that's 86. But we have two different starting points. If you think about this as a travel analogy, if I want to go to the store, if I start from my house, I have to travel farther than if I were to start from the parking lot. Okay, so my starting points aren't the same. So my distance traveled can't be the same. It's the same way here. So I started 1 unit closer. So what does that mean about the distance that I traveled? It must be 1 unit smaller, which is why that works in terms of the distance that we go. Okay, so let's keep going on with these. The first hundredths chart below shows a way to find 39 plus 47. Okay, starts here and it goes down 1, 2, 3, 4 rows and then over 7 ends at 86. On the same hundreds chart, show why 40 plus, and we said this was 46, gives us the same answer. Okay, so we're still going to start at 40 or 39. And actually, we're going to start at 40. I apologize because we're showing the compensated method. And we're going to add 46. So 10, 20, 30, 40. And now we need to travel 6. 1, 2, 3, 4, 5, 6. We end in the same spot. Okay, now we're going to use compensation for this problem and model it similarly. Okay, so here we're doing subtraction. We're going to start with 74 and we're going to take away 33. Okay, and the compensation that this person has chosen to use is to adjust this to 30. Okay, so it helps me, especially because subtraction might, in some ways, is a little bit backwards. We have to kind of make sure we are thinking clearly about it. Okay, so I'm going to be taking away 3 less. Okay, what would that normally do to a sum? If we kept everything else the same and I just took away 3 less, that normally would increase my ending value by 3, right? I'm taking away 3 less, so that would leave you with 3 more. If I don't want that to happen, I'm going to have to compensate that first number for this extra 3. So in order to balance it out, I would have to subtract 3, okay? And that would put me at 71. Now, regardless, if we were to stack this up, now again, this is what we're trying to avoid, okay? But if we were to stack this up and do the calculation, we want to have the same endpoint. Okay, we want to have the same endpoint. That's happening here. So there's my thinking for the compensation. Now we want to show that on the number line, okay, to again verify why this works out. So I'm going to go back to my black color here and I'm going to draw my number line. And I know I need to go from about 30 up to 70. So I think I'm sorry, I need to at least start at 70 and come down to at least 40. So I'm going to start this at 35. And again, I'm going to break it down by 5s. Okay, so perfect spacing there. All right, now I'm going to do, again, just like I did last time, the uncompensated version in pink. So we'll start at 74, which is right here, approximately right here. That's my 74. And I want to take away 33. Okay, So let's kind of visualize this. When I get down to 70, I have already taken away 4, okay? And that leaves me 29 more to reduce this by. So there's 10 to 60. There is 10 more, so 20 when I get down to 50. Okay, so far I've taken away 24. And I want to take away 33 altogether, so I need 9 more, which would take me down to 41. Okay, so that would be my additional 9. So I still end at 41. Here I started at 74 and I traveled the distance of 33 units to end up on 41. Remember what we said, we always have the same end destination in mind. That's why this works. Okay. So I'm starting from a different place. Instead of starting at 74, now I'm starting at 71. Okay. So what did I do here? By changing my initial start position, I gave myself sort of a 3-unit head start. Okay. So I want to end at the same place, but since I gave myself that 3-unit head start, what that ultimately is going to do is it's going to change my distance that I need to travel. Instead of traveling 30 units by starting way back here, now I only have to travel 30 units instead of the 33 we have there. Okay. So same thing down here on the number chart. We can show that. It originally shows us why 74 minus 33 ends at 41. So we go to 64, that's 10, 20, 30, 1, 2, 3. Okay, let's do the same thing with the compensated answer that we gave, which was 71. Okay, so I'm going to start at 71 and I'm going to remove 30. 10, 20, 30. Okay, so we end in the same spot. That's always our goal. Okay, we want to end in the same spot. What we do get to adjust is where we begin. And of course, that's going to affect the distance that we travel. Okay. So I'm going to stop sharing there, and I'm going to put these other problems on their own video because they are a different kind of thinking.